Well, the key elements to the roles of being a scientist are very different than the key roles of being a university president. When you're a scientist, one of the things you must learn to do is to focus intensely on your own field and to become the commander of every single fact and figure about the field. In my case, it was molecular biology. And to narrow down and dig deep into the field. And what I discovered when I became the president of Princeton is that skill was not a good skill, because there I had to be responsible for an enormous breadth of activities that the university is engaged in. And going deep in any one of them would have spent far too much time on any given thing. So I had to learn a very different skill, which is the skill of being able to go very broadly across many, many aspects of the job. I think the first important thing about being a successful scientist is you have to actually have a passion for it. It almost has to become a calling. And so you have to, first and foremost, you have to really love it. And then it does require that you work hard. But if I had to give a piece of advice about how to determine whether this is the right calling for you, I would advise young women to get into laboratories as quickly as possible. It's the doing of science that will tell you whether that is something that you really love and you really want to do. And I had the great advantage of being able to do that in university, working in faculty labs and discovering that I really did have a passion for it. And if you think about the kinds of skills that is required to be a university president, I would say the skill set that was most important to me was the ability to listen, the ability and the instinct to want to hear people's stories, whether it were students who wanted to tell me about what they wanted to do in university, faculty who had very particular interests in mind, and indeed alumni who had aspirations for the university that I needed to hear. So I think being a good listener was one of the most important things about being the president of Princeton. So the answer is yes and no. I always wanted to be a scientist. From a very young age, I fell in love with numbers as a child. And then as a high school student, I actually fell in love with the periodic table, which I found to be immensely orderly and made a great deal of sense to me. So I always knew I wanted to be some kind of a scientist. It took some time for me to figure out that the field that I would excel at, most likely excel at, was molecular biology. But I never for a moment thought I would be a university president. I didn't really know very much about what university presidents did. It didn't seem terribly interesting to me compared to being a molecular biologist. But because I loved Princeton, and because I served on the search committee and so had 7 or 8 months in which to learn what university presidents did, I came to understand that would be the best way to spend the next decade or so of my life. So on the one hand, yes, on the other hand, no. So with respect to being a scientist, the most challenging were coming up with the great ideas for experiments. You ultimately as a scientist are judged by the questions you ask and the skill with which you ask them, and ultimately whether you can actually answer the question. And that was by far the most challenging part of being a scientist. The most challenging part about a university was understanding the institution well enough to know how to make progress in a way that brought the entire community along with you. Universities are not command and control organizations. They are organizations that make decisions by consensus building. And so the biggest challenge for me was beginning to learn how to develop ideas and then to build the consensus around them that was needed to ensure that they would actually be executed. Well, ironically, the best advice that I was given at the very beginning of my career was not to be a chemist. So I had a wonderful professor in university. I was a chemistry major at the time, who came to me one day and said, "Shirley, you're really smart. You work hard. I can see you work really hard, but you just don't have the instincts to be a great chemist. You should go look for something else to help you along and to inspire you." And that was actually, although it was hard to hear at the time, it was the best advice I was ever given, because he was absolutely right. I was doing well in chemistry mainly because I worked like a dog, but it didn't come naturally to me. And when I discovered molecular biology, then I realized what it felt like for it to come naturally. So sometimes hard advice can be the very best advice. I think I would advise girls to do a couple of things. One is to, as quickly as possible, find a way to initially maybe just observe in a laboratory and ultimately to work in a laboratory. Because I worry very often that science education is often portrayed as memorizing a bunch of dry facts and giving them back on an examination. But that's really not what science is about. Science is about getting your hands dirty, getting into a laboratory and actually doing it. So my advice, if you think that this is something that you're interested in, try and have that experience as early as possible.